This is a math tutorial on quadratic equations, which is the second chapter under algebra. First, to give you a little background on quadratic equations, it's any equation. I hope you know what an equation is. It's any equation of the form ax square plus bx plus c equal to 0. And in this, a, b, and c are all variables. They're all variables. And there's one condition attached to this. This will only be a quadratic as long as a is not 0. I'll just give you the reason for that. You may have learned before in middle school that uh, in any algebraic expression, the degree of the polynomial is the highest degree of x. So in this case, you can see over here the highest degree is clearly 2, which is any equation whose highest power is 2, which means its degree is 2, is called a quadratic. Similarly, if it's 3, it's called cubic. If it's 4, it's called biquadratic. What you've been doing so far, where the highest degree is 1, that is called linear. So just moving one step ahead now. And that's precisely the reason why a cannot be equal to 0, because if a is 0, all you're left with is bx plus c. And as you can see, the highest power of x is just 1. So this is a linear expression. It's not a quadratic. Okay. Also, b and c are free to be 0. There's nothing restricting them. If b is 0, you'll be left with ax squared plus c, which is perfectly fine. If c is 0, you'll be left with ax squared plus b. And if both b and c are 0, you will just be left with x squared equal to 0. It's only the a which cannot be 0, and that should be pretty clear to you. Just remember this for sure. Okay. Besides this, there are a few important formulae you need to know. The first thing you need to know is something called the discriminant. Now, to solve any quadratic equation, you'll need to make use of this discriminant. It's the formula for finding the discriminant. It's just a number. It's b square minus 4ac. And here, of course, the b is this b over here, and the a and c as well are the ones over here. Okay. B square minus 4ac, it's a number that tells you about the nature of the roots of the equation. Every quadratic equation rather, has two roots, and that's because its degree is 2. And every cubic equation will have 3 roots. Every biquadratic, which is to the power 4, will have 4 roots. So it tells us about the nature of the roots, and by nature you mean, I'm just gonna write nature. Also, you should note that roots are also called zeros at times. So if the question asks you to find zeros, then don't get confused. You have to find the roots, which is possible values for x. So I'm just gonna write roots here. Oops. Okay. So now if this value of b square minus 4ac comes out to be, I'm just going to write as d, the whole thing is d, discriminant. So if d is more than 0, this means that the roots of the equation that you will get will be real and distinct. You need to remember this. It'll be real and distinct. If I'll explain this later, I'm just gonna write all of them before. If d is equal to 0, roots, both the roots will be real and equal. Real and equal, equal means that both the roots will be the same. So actually you'll get just one value. I'll come to that later. And the third possibility is, of course, d is less than 0. And what you get here is non-real roots. And these are called imaginary as well. So write non-real. Okay. And so from this you can figure out that if you want real roots, d needs to be either more than 0 or equal to 0. Sorry, my d is deformed. Okay, so for real roots it needs to be more than equal to 0. So this is basically how you find the nature of the roots. Now coming to what is real. Real, you should probably know by now, it's all rational, irrational numbers, whole numbers, natural numbers, fractional numbers, all decimal numbers, everything except for complex numbers and non-real numbers, imaginary numbers. You learn more about those next year if you take math. But for now, you can leave it at here. Real numbers are basically those which you can plot on a number line, so you can remember it that way. Now, distinct. If d is more than 0, distinct means that you will get two roots which are different from each other. So you'll get, for example, 1 comma 2. Both of them are distinct, which means they're different from each other. If d is equal to 0, you'll get real and equal roots. So for example, 5 comma 5. If d is less than 0, you'll get a non-real root. Now we'll come to that later, because I'm not sure whether you do non-real roots in detail this year. So you can leave it here for now, but you don't need to bother much about this in grade 10. You can leave this. So the only questions that are asked on this topic in grade 10 is find the nature of the roots of the expression so and so. Okay, so I'll just give you an example. X square plus 2x plus 4 equal to 0. First things first, identify A, B and C. So A, you could guess from here, it's actually 1x square. You could write this as 1x square. So A is 1. B similarly is 2. C is 4. Just apply this formula, b square minus 4ac. So take the square of b, that's 4, minus this 4 into a, which is 1, into c, which is 4. So you get 4 minus 16, which is definitely negative, minus 12. So now just compare it to this over here. D is less than 0, so the condition that you satisfy is this one. So you'll get non-real roots in this case. So all you have to write is non-real roots. That's your answer. Also, one more question that is asked is, they'll give you an equation, but they'll give you what they'll give you is not just a, b, c and x square, but they'll give you a variable. They'll give you, say, kx square, and what you have to do is find k, or any variable, whatever they've named it, such that that equation will have real or non-real or equal or any type of roots. So in those things, all you have to do is just identify what are they talking about? Are they talking about d more than 0, d equal to 0, d less than 0, or do they want d more than equal to 0? Just identify that, and you must have done linear inequations by now. So all you have to do is, this is d over here, b square minus 4ac. So just equate this, make it more than 0 or less than 0, and you'll get an expression in k, and you'll get a certain value. In fact, you get a range of values, not just any value. That's it for this section. I'm running out of time, so I'm going to be carrying this on in the next video.